Okay, this is a Unit 7 preparation video um, for the refresher course. And Unit 7 deals with trigonometry. And in the freshman calculus course, of course, there's no use of any calculators, graphing calculators or otherwise. And so a little refresher on the trigonometry of special angles, and those would be the 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and multiples thereof. And those measurements, of course, relative to the sine ratio, relative to the cosine ratio, and relative to the tangent ratio. And additionally, of course, relative to the reciprocal functions, uh, cosecant being the reciprocal of sine, secant being the reciprocal of cosine, and of course cotangent being the reciprocal of tangent. Now, for sine, the sine of 0 degrees is 0. The sine of 30 degrees is 1/2. Okay. The sine of 45 degrees is square root of 2 over 2. The sine of 60 degrees is the square root of 3 over 2. And the sine of 90 degrees is 1. Now, in addition to that, the cosine at 0 degrees is 1. The cosine at 30 degrees is square root of 3 over 2. The cosine of 45 degrees, square root of 2 over 2. The cosine of 60 degrees is 1/2, and the cosine of 90 degrees is 0. And then in regard to the tangent of 0 degrees is 0. The tangent of 30 degrees is 1 over the square root of 3. Or you may, of course, want to rationalize that. If you, uh, if you want to multiply top and bottom by square root of 3 over square root of 3, then you would get square root of 3 over 3 as your answer with a rational denominator. The tangent of 45 degrees is 1, and the tangent of 60 degrees is the square root of 3. Okay. Finally, the tangent of 90 degrees is undefined or does not exist. Now, in terms of how you're going to commit these to memory, we'll say, first of all, it needs to be noted that the degrees are going to go away. All right. In the freshman calculus, you won't be discussing angles in terms of degree measurement. Instead, we'll be using something called radian measurement that you may be familiar with. And so let me just plug in here what the radian measures would be in each of these cases. Now, formerly known as 0 degrees is 0 radians. Okay, so this is the radian scale that I'm putting down here. And 30 degrees is known as pi over 6 radians. 45 degrees is pi over 4 radians. 60 degrees is pi over 3 radians. And 90 degrees is pi over 2 radians. All right. So there's the chart that handles the first quadrant angles that you should be familiar with. And then put that together with the idea that there's 4 quadrants and all should be well. Of course, this is your first quadrant where both x and y are positive. Second quadrant here, where the y value is positive, but the x value becomes negative. Third quadrant, both x and y negative. Okay. And finally, the fourth quadrant, where the x is positive again, but the y value is negative. Um, in addition to that, you need to know that in the first quadrant, of course, all of the trig functions are positive: sine, cosine, tangent, secant, cosecant, and cotangent. All right. In the second quadrant, the sine function, and of course its reciprocal, cosecant, would be positive. In the third quadrant, the tangent and its reciprocal, um, cotangent, just the flip, right, are positive. And in the fourth quadrant, cosine is positive, and um, its reciprocal, which of course is secant. Okay. Now, you may have another technique that you've learned from the high school realm of how to come up with these exact values. Um, some people use some reference triangles. Some people have committed to memory what's known as the 30, 60, 90 triangle. This being 30 degrees, this being 60 degrees, which is fine, but again, the degrees are going away. So this 30-degree measurement is now a pi over 6, and the 60-degree measurement is now pi over 3. Of course, the ratios stay the same. The hypotenuse gets represented by a 2. The shorter of the two legs gets represented by a 1. And the longer of the two legs gets represented by square root of 3. And then from here, you can do your sine, cosine, tangent, or the reciprocal functions for either the 30 or the 60, the pi over 6 or the pi over 3 angle or reference angle. Right? Then the 45-degree angle gets handled by an isosceles right triangle. And so again, in degree measurement, which is going away, these are 45-degree angles. Well, consequently, that means the two legs are the same length. They're in the same ratio. Doesn't mean they're both necessarily ones, but they're in the ratio of 1 to 1, right? And then the hypotenuse ends up being whatever that leg is times the square root of 2. So again, degrees going away, so 45 degrees is now going to be noted as pi over 4. And from there, again, you can pick up sine, cosine, tangent, or any of the reciprocals based on this diagram. Still, other people use a circle to do this sort of thing. And in order to do that, I'm going to clear some things out. I'll get rid of this chart over here, and we'll show the other rendering that some people use to uh, to reference these. And so the idea goes, not a real good circle here, but I guess it'll serve. Um, as you move around the quadrant at the various points of interest, pi over 3, pi over 4, pi over 6, right, pi over 2, you can notate the xy values, which in a unit circle correspond to the cosine and the sine in that order. In other words, at pi over 6, which is 30 degrees, the cosine of 30 degrees is square root of 3 over 2. The sine of 30 degrees is 1/2. So the xy values, the abscissa and the ordinate, are the values of the cosine and the sine, respectively. Now, at pi over 4, at 45 degrees, they happen to be the same. Square root of 2 over 2, typically written square root of 2 over 2. Again, it wouldn't be a problem if you wanted to write that as 1 over the square root of 2. And then pi over 3, or 60 degrees, the cosine of 60 degrees is 1/2, and the sine of 60 degrees is square root of 3 over 2. Then, as we continue around this circle, we can still reference those points. Um, For instance, at 3 pi over 4, and 3 pi over 4 would correspond to, if you're in degree measure, would correspond to 135 degrees. Well, at 135 degrees, at 3 pi over 4, your cosine, your x value, is going to be negative. Let me take out these parentheses for just a moment. Um, your cosine is going to be a negative square root of 2 over 2, and your sine is going to be positive square root of 2 over 2. Now again, the cosine is the x value. We already noted cosine is going to be negative in quadrant 2. Sine is going to be positive in quadrant 2. So these values are exactly the same as those first quadrant values correspondingly. In other words, at 120 degrees, right in here, you're going to have a negative 1/2 for your cosine, and you're going to have a positive square root of 3 over 2 for your sine. So the value you see over here in the first quadrant corresponds to the position horizontal to that in the second quadrant. All right. So this would be 2 pi over 3 as a radian measurement, right? And then 5 pi over 6, 150 degrees. 5 pi over 6 is directly across from pi over 6, and consequently, the cosine is going to be a negative square root of 3 over 2, and the sine is going to be a positive 1/2. Again, sine is positive in the second quadrant. You'll notice all the y values for each of these points that I've just identified, all of the y values are positive. All of the x values are negative because you're in that second quadrant. As you continue to move around, uh, this stays true to form. So when you're in the third quadrant at 7 pi over 6, which corresponds to 210 degrees, you're going to have uh, a cosine of negative square root of 3 over 2 and a sine of negative 1/2. All right. And uh, notice, since you're in that third quadrant, since that angle would be in the third quadrant, both the x and the y are negative, and so that's why you're seeing two negative values there. Um, when you get to 5 pi over 4, then that ends up being negative square root of 2 over 2 and negative square root of 2 over 2. So now both the x value and the y value are negative, and you can sort of see how now we're corresponding above the y-axis to the point, say at 3 pi over 4 is negative square root of 2 over 2 and square root of 2 over 2, and symmetrically at 5 pi over 4, now below the x-axis, right? So both values are negative. It's the same two absolute values, but the signs just change as you move around the unit circle. So finally, when we get to what would what would correspond to 60 degrees, right, in the third quadrant, when we get to when we get to 4 pi over 3, we get to 4 pi over 3, right? Um, that's going to turn into a cosine of negative 1/2 and a sine of negative square root of 3 over 2. All right. So continuing around the circle and now into the fourth quadrant, you're going to see this same value here, right? Tracking across from 4 pi over 3 to 5 pi over 3, okay? You're going to get the exact same absolute xy values. It's going to be a 1/2, and it's going to be negative square root of 3 over 2. Now notice what happened as we went from one point to the other point. The only thing that changed was the x value sign, plus or minus, I'm saying, S-I-G-N. The x value went from negative 1/2 to positive 1/2. The y value is the same. They're both negative square root of 3 over 2. Right? And then as we continue around to the angle that would correspond to 5 pi over 4, as we go to 7 pi over 4, it's going to be negative, sorry, positive square root of 2 over 2 and negative square root of 2 over 2. Again, same numbers, absolutely, but now the x value is in a plus direction, so it goes positive, right? And finally, when you get to uh, 11 pi over 6, I need to make a little more space here. When you get to 11 pi over 6, which corresponds to a reference angle of 30 degrees, right? All I'm saying is this value over here that you saw in the third quadrant, negative square root of 3 over 2 and negative 1/2, is going to be the same value absolutely here in the fourth quadrant. Or if you prefer, if you want to look up here in the first quadrant at pi over 6, we have square root of 3 over 2 and 1/2. Of course, both positive. The x is positive, the y is positive. Well, now when you go to 11 pi over 6, your x is still positive. It's going to be a square root of 3 over 2, but your y value is negative. So your y value is negative 1/2. All right. So some people use this unit circle and the idea that the cosine is the x value and the sine is the y value, and some people prefer that technique of memorizing these. Of course, then from there, you're directly reading the cosine and the sine. Easy enough if you know the cosine and the sine to come up with the secant. You would just flip whatever the cosine is. You would just do a reciprocal, right? And easy enough to come up with the cosecant because that's just going to be the flip of the sine. But what of the tangent, right? Well, remember, definition of the tangent of an angle is the ratio of the opposite leg to the adjacent leg in a right triangle. Okay? Well, if we look at the sine ratio, which is opposite over hypotenuse, and cosine is adjacent leg over hypotenuse, we can see that all we need to do to determine the tangent, if you're going to use this model, is you just divide whatever your sine ratio is by whatever your cosine ratio is. Okay. Now let me just example you with that, right? We'll leave the chart up there, even though it's difficult to read. I realize that. Suppose you want the tangent of, we'll say, pi over 3. Well, you can memorize it from a chart, okay? But if you're going to use this unit circle concept, okay, what you would do is find the sine of pi over 3, right, and divide it by the cosine of pi over 3. That's all we're saying that you would need to do. So pi over 3, our sine is 1/2, and our cosine is square root of 3 over 2. So your tangent of pi over 3 is going to be 1 over the square root of 3. Now, we realize that many people get in the habit of rationalizing their denominator. So 1 over square root of 3 would be an acceptable answer. Although you could, if you remember your high school trigonometry, you could multiply top and bottom by square root of 3. And so you get square root of 3 over 3. And that would be an acceptable answer as well. All right? So some way or other, minus a calculator, you need to be able to do sine, cosine, tangent, and the reciprocals of those trigonometric functions. If you want to use the unit circle technique, great. If you want to use the reference triangle technique and then put yourself in the right quadrant, being careful of whether things are positive or negative, um, that's a good method. Um, of course, the other method is to memorize a table of values for sine and cosine. Um, that's a good method. We don't really recommend any one, just that you're able to fairly rapidly be able to obtain the exact value, meaning you leave a radical in your answer when necessary, uh, of of the basic 0, pi over 6, pi over 4, pi over 3, pi over 2, and multiples thereof, uh, angles. Okay, so that's just a quick refresher on high school trigonometry. If you have more questions, please don't hesitate to get back to us.